Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today topic we are going to discuss the tutorial question bank, the module 4. The topic is Fourier series. First of all, we need to discuss what is the syllabus and again what are the topics which is covered and again what are the basic formulas and again what is the procedures and again we'll go to discuss regarding all these things, and after that we'll go to discuss that clearly about the question bank. In previous sessions we discussed clearly the model 1, model 2, model 3 is completed, and today that is a model 4. And moreover, and what we are going to discuss the today, that is a model 4, we discussed the previously in that lecturers each and every topic wise we discuss properly. Here, according to that syllabus wise, that is a model for the Fourier series. Under here, the topics which is covered on the Fourier's expansions of periodic functions in a given interval of, that is length is 2 pi, and again under the Fourier series the even function and odd functions and also including the neither function also, and again these are the particularly we are going to discuss under that 0 to 2l 2 pi limits, and again after that based upon the Fourier series in the arbitrary intervals and again especially and again in that arbitrary intervals like 0 to 2l and again that limits and again including the finally that is half range series, and again half range series that based upon the Fourier half range cosine series and Fourier half range sine series, that we are going to discuss in the depth wise. And again here before going to discuss that also, here these are the like part A wise and again next one is the part B side. The part A is nothing but it is covered under the limits are like 0 to 2 pi and 0 to 2l, that is a full range series, and again whereas in the half range series that is covered on the 0 to pi and also 0 to l, like according to the periodic function pi in terminology and also the arbitrary period that is a L terminology. See, that is before going to start the Fourier series we need to discuss that particularly that is a what are the basic formulas which is covered under in the Fourier series. Here the basic formulas is nothing but we discuss in the like in the previous sessions, and also moreover we studied in intermediate level also. The first one is the basic fundamental formula which is involved here, that is a Leibniz formula. This is main important under the Fourier series we need to remember, that is a Leibniz formula is also nothing but it is called as integrating by parts. Okay, and again any recall that according to the integrating by part formula, it is integration uv into dx. The integration of uv is nothing but as we know that according to in the nth integration like that formula, basically it is a uv1 minus u dash v2 plus u double dash v3 and again minus up to so on. That means it is a plus and minus, it is a plus minus like all these terms according to that is a alternate series. And here we need to understand what is the meaning of the like u to u dash and u double dash and u triple dash and v to v1 v2 v3 like that conditions. While we are observing here, it is a and integration uv is also nothing but it is a integration udv also, both are the same. If it is a comparison that udv is equal, that is a uv minus u dash v1 and again plus u double dash v2 up to so on. Either we need to follow any one of the formula, both are in that in different terminology. Here while we are going to generally here we are going to using this is the integration uv. Here the second one is also no problem, we need to consider that integrating by parts, that is a Leibniz formula. And again what is the meaning of u dash u double dash like that, and generally that derivatives that u dash and u double dash and again up to that is condition is the derivatives. That means u to u dash first derivative, u double dash that is second derivative up to so on. And again similarly v to v1 v to v3 will like that v3. That means that v1 v2 v3 is a like successively that is the integration parts. Whatever the v that is integration v1 is nothing but one integration, first integration, vt is nothing but that is the second integration up to so on, increasing the integration wise. That depend upon what we are going to priority, like what how to consider what we are going to assume that u and also v, that is based upon as we know that the choice of the islet conditions, or that is nothing but Liet. Both are nothing to worry, that is islet or that is a islet also. Liet or Ilet. And as we know that according to the Liet, the meaning of Liet is nothing but that L is nothing but it is a logarithmic terminology. The logarithmic is nothing but it is in terms of the log x. And again the I, I is nothing but that is inverse trigonometric functions. The inverse functions. That means according to that is sine inverse x and also something like that cos inverse x or something any terminology that is inverse trigonometric. And again the algebra functions. And again algebra function is nothing but the functions which are occurring in the polynomial. That is nothing but x gani, x square ga, x cube like that, x plus x square like any terminology. That is the meaning of the algebra. And again moreover the t is nothing but that is a trigonometric functions. The trigonometric function is nothing but as you know that is a sine terminology, cos terminology and also the tan, log something whatever that is a trigonometric which is a sine, cos, tan, secant and also cosecant. And again the exponential that is nothing but that is exponential. That exponential is nothing but in terminology of that is a e power x, e square, e power minus ax, like that e power minus x or something e power 2x. That depend upon that any condition of that e power x. That is exponential the terminology. And based upon that, according to we need to give the priority for that Leibniz formula like Ilet or like that Liet conditions. And based upon this, give the priority according to U and also V, then find the solutions. This is a generally we need to follow that is a Leibniz formula. And again, after understanding this one, that is a Leibniz formula. And again, for example, the basic like a few examples we need to observe that how to what is the first derivative, second derivative like that. For example, x power 4 that is a 4x cube, and one more derivative that is a 12x square, and one more derivative that is a 24x, and one more derivative that is a 24. That means these are according to one by one we obtain the derivatives with respect to dash dash like that, first derivative, second derivative like that and other terminology like that x power 4 for example one integration that is x power 5 by like 5 and again one more example that is x power 6 by that is 30 and again x power 7 that is a 7 into 6 into 5 and again one by one it is increasing level that is the integration and again similarly for example trigonometry the cos x is nothing but the integration is a sin x by a and one more it is a minus cos x by a square and again similarly minus sin x by that is a cube like these are the continuation some of the integrations which are helpful for according to this is the Fourier series and again coming to that one more that is integration that is a sin x the integration sin x is also minus cos x by a and again further minus sin x by a square and further it is a cos x by that is a cube these are the according to one by one increasing level that is a one is a first one is a derivative and again remaining the like integration the continuation extend the one by one the terminology and these are very helpful for this chapter that is a model 4 we need to remember and again the Leibniz formula for example we need to consider this is the for example it is a consider u and also v it is u and also v and based upon that according to by the formula it is the first one is a u that is x square and derivative of x square is the x 2x and one more derivative is a that is a 2 and again after that 2 there is nothing no more value that is a 0 therefore we need to stop up to that u dash and also u double dash and again the formula v to v1 whatever we assume that v that is a sin x integration is a minus cos n x by n and again further one more integration that is a minus sin x by that is n square and one more it is a cos n x by n cube and alternate formula is a one is a plus minus and also plus and also minus these are the according to that alternate terminology these are the simple understanding level to find out the integrating by parts easy to understand the conditions and similarly any problem is given we need to follow according to these integrating by parts and for example yeah this is the finally after that simplification we obtain this is the solution see for example exponential formula this is also important for understanding here e power ax into sin bx here it is a e power ax by that is a square plus b square and again a into sin bx minus b into cos bx is the formula and again plus c is the constant and formula integration e power ax into cos bx e power ax by a square plus b square and again a into cos bx minus it is a plus b into sin bx is the formula yeah these are very important to understand to remember the conditions for example this is the a is equal to and b is equal to n we need to remember according to this the formula finally this is the solution And trigonometric functions, and again generally cos 0 is equal to 1 and sin 0 is equal to 0, and again cos n pi is equal to the value is minus 1 over n, and again the sin n pi is also something values, and again cos 2n plus 1 into pi by 2 is equal to 0, sin of 2n plus 1 into pi by 2 is equal to the value is minus 1 over n is the value. And again we need to remember that according to these are also some important. Whenever the generally f of x be an interval in the limits are like according to minus L to L is a fundamental, we need to remember that is f of x is even function under the limits are in between minus L to L f of x into dx. The output will be it is a 2 into integration 0 to L f of x into dx is the value. But in case of the function is a like odd function in between that minus L to L, that f of x and dx, the value is a totally the value is a 0. And periodic function, the definition of periodic function you need to understand that a function f of x is said to be periodic function with period is greater than 0 if for all values of that f of x plus t is equal to f of x for all values of x. And it is a t is a small periodic function, that is a primitive period of f, and that is denoted that is a primitive period of f is also condition considered. And generally sin n x, cos n x, secant x, cosecant n x is the periodic functions with the period that is 2 pi by n, and moreover the tan n x and cos n x the periodic function with period is pi by n is a value. And even function, and again how to identify the even function, what is the definition, and again what are the characteristics like that according to. And again similarly after this slide that is a odd function and also neither function is also important to understand. Here the even function, as you know that the function is said to be even function, generally f of minus x is equal that is a f of x. And again similarly if an even function, as we know that in the previous session, that is a previous slide, that is integration minus L to L, but it is also minus A to A, because we assume that the limits are in brackets of L is equal that is A, that is f of x into dx is nothing but 2 into integration 0 to A f of x into dx. And examples are like according to these are the example for the even function like x square, x power 4 and x power 6, and again that is x power m where n is a positive number. And in other example every constant function is also like that even function. And here the cos x, like the function is also in the trigonometric function, the cos x is also even function, and moreover the graph of a symmetric function is always showing it is a y-axis. And again similarly odd function, a function is said to be odd function such that the f of minus x is equal that is a minus f of x, and based upon that f of minus x is equal to minus f of x, the general value that is a minus a to a f of x dx, the value is a 0 value. And again examples are like according to the even function x square, x power 4 up to so on, but odd function the value is a x cube and again up to so on, x power m, based upon here m is any odd value. And moreover in the trigonometric function, that is sine is also suitable example for the odd function, and again graph of an odd function is always passing through the origin. And neither function is nothing but other than the even and also odd. That means whatever the function is f of minus x is nothing but that is f of x is even function, and f of x is equal to minus f of x is a odd function. But other than this condition is nothing but it is not at all equal. It is not at all equal, means not even any one of the condition is not satisfied. Therefore, the function is said to be that is a neither function. That means it is not a neither the even function, not a odd function. And again, the best example for the neither function, it is a e power of ax. And again, other example in the trigonometric, that is a x plus x square. And again, if you want to equate, that is x minus x square, and again ax power m plus bx power n is also that based upon the m comma n, and also the functions are the odd functions, like n is even and also m is odd function, the function is neither functions. And next one we need to keep in our mind, that is Dirichlet conditions. Before going to discuss that question mark, these are the very important to remember this. Without remembering this one, it is not possible to discussion of that question mark. That is what we are going to do. That is a Fourier series. Okay. And again, the Dirichlet conditions for existence of Fourier series of f of x is the condition. And what are the conditions for the Dirichlet conditions that we need to keep in our mind? F of x is bounded. That bounded is nothing but it is a like limits are exist like including the lower bound and also the upper bound. And also that f of x is a single value. That means by the calculation any function like that we are getting only the single value. We are not getting any different type of the values. That is a single valued functions. And f of x is a finite number of maxima and minima of the given interval. That depend upon the ending problem we obtain the maxima. And again that f of x has the finite number of discontinuous in the interval. At that time the condition is satisfied, the f of x is a like sin inverse x which is not a single valued function. And tan x it is also not defined in the interval. And similarly it is also not conditions. Like these are the one condition is important to remember, that is a bounded, and again the next one is a single valued, and the third one it is a finite number of maxima and minima in the interval, and again the finite number of discontinuous in the interval is the conditions. If these are the conditions are satisfied, then the function is a Dirichlet condition is a satisfied. And next one, whenever the function is a discontinuous at that particular limit, when you are going to replace in the given function, if the limit is not a continuous, that the not continuous is nothing but the function is a not existed. The not existed is nothing but it is a LHS limit and RHS limit both are the not equal. That means whenever the LHS limit and also RHS limit is a not equal, the function is a not exist. If it is a not exist means it is a not a continuous. It is a not continuous means it is a discontinuous function. And then at the time how to reduce it to like that continuous function, that is the meaning of whatever the particular value like LHS limit and also RHS limit, we make it that is a average. That means 1 by 2 of that is a LHS limit and also that RHS limit. That is the meaning of 1 by 2 into that is a LHS limit plus that is a RHS limit at that particular point, that is x is equal to that particular point of the limit. Example like for example this point, it is a for example at x is equal to pi. This is the function at x is equal to pi. That pi is nothing but it is a here also pi is equal to minus pi, and again here pi is nothing but this is the function. That means at x is equal to pi the LHS limit is a minus pi, and again the RHS limit is a at x is equal to pi the value is a 0. That means at x is equal to pi we need to replace pi minus pi in the second function, we get the value is 0. And again while we are going to observing this one, the LHS limit is minus pi and again the RHS limit is a 0. Therefore LHS and RHS is not equal to same. Then the function is discontinuous at the particular x is equal to pi. Then if we make it like that continuous function at x is equal to pi, therefore that is the meaning of average of that is LHS limit and again plus that is the RHS limit. That is nothing but here 1 by 2 into the LHS limit is minus pi plus RHS limit is 0. Therefore it is a conclusion, it is a minus pi by 2 that particular point of the given function, it is a continuous function. And types of the intervals means under this Fourier series what we are going to discuss the types of the interval, that is nothing but two categories. One is a 0 to 2 pi and also 0 to that is a minus pi to pi. Actually these are the two different like intervals are under the 2 pi limits. One is 0 to 2 pi is also full range series, and again minus pi to pi is also full range series. That means these are the two particularly the methods we are going to discuss under here. This is the schedule. Here first of all, what is a Fourier series before going to discuss that 0 to 2 pi and also minus pi to pi. In generally, the Fourier series is defined based upon that let f of x be a periodic function with a period 2 pi defined in the interval c comma c plus 2 pi can be expressed as a trigonometric series as that is a f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n x plus b n sin x, where the values are here. That f of a function, the Fourier series is known as a Fourier series function for f of x, and where a0, a and bn are called the Fourier coefficients, are also called as a Euler coefficients of f of x. That means whatever the series in this, that a0, a and bn are called the Euler coefficients or Fourier coefficients. And again here the values are like a0 is equal to 1 by pi integration c to c plus 2 pi f of x dx, and also that n is nothing but c to c plus 2 pi f of x into cos n x dx, and similarly the bn is also 1 by pi integration c to c plus 2 pi f of x into sin n x into dx. These are the Fourier, this is the Fourier series for particularly the Fourier coefficients are a naught an and also an and also bn. These are the limits under the prescribed, that is a c2, that is a c plus 2 pi. And again here, when we are going to replace that in terms of in this, c is equal to 0, the values are 0 to 2 pi, and c is equal to minus pi, the interval limits are minus pi to pi. That means entirely the Fourier series based upon this is the Euler coefficients formula. We need to find out in that required given any series. First we need to find out the related the Euler's Fourier coefficients. Then after that we need to replace in the Fourier series. For example, the limits are 0 to 2 pi. Here, under the 0 to 2 pi is nothing but, what did I say, just c to c plus 2 pi. Here in branch of, that is a c is equal, that is a 0, then automatically the limits are changed like that, 0 to 2 pi. That means a naught is nothing but 1 by pi, that is 0 to 2 pi f of x dx, and n is nothing but 1 by pi, 0 to, that is a 2 pi, and f of x into cos in x, and bn is nothing but, it is a 1 by pi integration 0 to 2 pi f of x into sin n x dx. And for example, the limits are under the minus pi to pi. That means we need to replace in the general formula c is equal to minus pi. Therefore, the series is like according to we obtain the same series. Therefore, a naught and bn are called as the Euler coefficients, and where a naught is nothing but 1 by pi minus pi to pi f of x dx, and bn is equal to 1 by pi minus pi to pi f of x into cos n x dx, and bn is nothing but 1 by pi minus pi to pi into f of x into sin n x dx. And these are the particularly from the general Fourier series according to from the Euler's coefficients, that a naught and bn in limits are like 0 to 2 pi, change the limits are 0 to pi, and replace that c is equal to minus pi, the limits are changed to minus pi to pi only. These are the two different type of the full range series obtained from the c to c plus 2 pi. Now the Fourier, the flow chart of that, while we are going to discuss the particularly this total flow Fourier series, we need to keep in our mind what is the flow chart. That means when we are going to find out that particularly the values are a naught and bn, that is a Fourier coefficients. If you remember according to this flow chart, entirely this Fourier series is easy to understand, that we keep in our mind, that is this is the flow chart. Here there is a full range series and also the half range series. As we know that the full range series is nothing but minus pi to pi, 0 to 2 pi, and again the half range series is nothing but the limits are 0 to pi only. That means based upon this one, the full range series is nothing but it is a divide like minus pi to pi and also 0 to 2 pi, and again the half range series is nothing but that is a 0 to pi only conditions. And once again, under the limits are minus pi to pi, if the limits are given, while when we are going to observing the given any problem, the limits are under the category of minus pi to pi, we need to identify these are whether the function is a even function, odd function, and also neither function. And again, under the 0 to 2 pi, like there is no conditions, but 0 to pi, the problem is based upon either the cosine series or it is a sine series. And based upon that, the function is under the limits are minus pi to pi, the function is an even function. We need to find out one is a naught and an, and the limits are minus pi to pi, the function is odd function. We need to find out only bn. And similarly, the function is a limits are minus pi to pi, the function is a neither function. We need to find out all the values are a naught an bn is a value. And similarly, the limits are under the 0 to 2 pi, there is no condition to find out whether the function is even or neither. We need to calculate all the values are a naught an bn is a value. And finally, the limits are under the 0 to pi. That means we need to particularly observe that whether we need to find out the cosine series or sine series. And particularly if it is a Fourier series is the Fourier cosine series, we need to calculate, that is based upon the cosine series is nothing but a naught and an. And similarly, the problem is under the 0 to pi, the function is a, if they are asking to find out that is a sine series, we need to calculate the value as a bn functions. This is the flowchart we need to keep in our mind while we are going to discussion of that is a Fourier series under this is a particular unit total based upon this is the condition. And if we remember this one, the arbitrary periods are also same. This is the applicable the conditions. And same the flowchart according to what in the previous slide, same this is also there is no change of that. And it is a even is a naught n, odd is a bn, neither is a naught n bn. and again here a naught a n is a naught a n b n, and 0 to pi is the cosine series and also sine series, and under the cosine that is a naught a n, and also sine series is a bn series. Yeah, this we keep in our mind according to while we are going to calculate the total the Fourier series. And further, Fourier series in the intervals are minus pi to pi. That means in the flowchart, whatever it is given, the limits are minus pi to pi. Then our concept is the function is even function or odd function or neither function. That even function is nothing but we need to calculate the functions are a naught a n only. That formula is obtained that a naught a n is nothing but here according to that a naught is nothing but it is a 2 by pi into integration 0 to pi f of x dx. After that modification, the function is even function. Finally, the formula is a naught is equal to 2 by pi integration 0 to pi f of x dx, and moreover a n is nothing but 2 by pi 0 to pi into f of x into cos n x. And similarly, the function is a Fourier series is odd function under the limits are minus pi to pi. We need to calculate only the value is a bn value. The bn is nothing but 2 by pi integration 0 to pi f of x into sin nx into dx is the value. That as per the flowchart, it is required to find out the limits are minus pi to pi, it is odd, that is a bn, and even is a naught an. And further, the limits are minus pi to pi, the function is neither function. We need to calculate a naught an and also bn. And the formulas are, it is there is no change of the limits like in between minus pi to pi. The limits are as usual, that is a naught is a 1 by pi minus pi to pi f of x dx, and an is a 1 by pi minus pi to pi f of x into cos nx, and again and bn is a 1 by pi minus pi to pi into f of x into sin x. These are the limits are under the minus pi to pi only conditions. The formulas for. And again next one, the limits are under the 0 to 2 pi for example. And as per the flow chart here, given that something suggestion to find out that is a naught a n bn only. Therefore, without any modification, the limits are like Euler values are a naught a n bn is a naught is nothing but that is a 1 by pi integration 0 to 2 pi f of x dx, and n is nothing but 1 by pi integration 0 to 2 pi f of x into cos n x dx, and again bn is a 1 by pi integration 0 to 2 pi f of x into sin n x dx. And coming to point, that is a half-range series. The half-range series formulas are like two types, that is half-range cosine series and also half-range sine series. And particularly half-range cosine series, to find out that a naught a n value only, that is a naught is nothing but 2 by pi integration 0 to pi f of x dx, and n is a 2 by pi integration 0 to pi f of x into cos n x dx. And similarly, half-range sine series. The half-range sine series is nothing but same based upon that we need to calculate only the value of bn only. Therefore, bn is nothing but 2 by pi integration 0 to pi f of x into that is sin nx into dx. These are the formulas under the limits are minus pi to pi and also 0 to pi. We need to keep in our mind again that 0 to 2 pi also. Yeah, arbitrary periods. The arbitrary periods is also nothing but same as usual. That conditions are according to the flowchart. We need to find the solutions. Yeah, like that half-range series is also same like that according to a naught a n bn. We need to keep in our mind whatever we shown in the previous slide, that is a minus pi to pi. Like minus pi to pi is nothing but the related minus pi to pi, the same condition minus L to L, and 0 to 2 pi, the same conditions on the 0 to 2 L, and 0 to pi, the same conditions on the 0 to L only. Whatever the flowchart given, like based upon the same conditions, we need to apply. Yeah, coming to point, we are going to discuss the like based upon that what we discussed in the previous slides, all the formulas based upon if you remember that easy to survive here, the question bank, that is a module 4 based upon the part A and part B, part C, same like the module 1, module 2, module 3, and here also part A is consisting like that 10 questions critical thinking, and part B is dividing like the 20 problems like essay type question, long answer question, and part C is like 20 like short answer questions. Now we'll go to discuss that according to how to find the solutions. Here the problem is under the critical thinking. Here the limits are, first we need to observe any problem is given, what type of the what are the limits are given the conditions. Here the limits are under the 0 to pi. The starting is 0 and again the upper limit is pi. That means here that according to that 0 to pi, here the two conditions are we keep in our mind, either the cosine series or it is a sine series. What is the series given? They are asking. In this problem, they are asking to find out that is a Fourier series only. Fourier series only. But in that Fourier series, what is the meaning of this one? It is not given that particularly Fourier cosine series or Fourier sine series. But the problem is critical thinking. But they want to give that according to actually under the 0 to pi, they want to give that Fourier cosine or Fourier sines. But it is not given that particularly any particular like name of the Fourier cosine or sine. But while we are going to observing, the problem is based upon it is a required series is in terminology of sine. That means the problem is based upon that you need to calculate Fourier sine series is the condition. That means we should not applying like that Fourier cosine series. Because of actually the problem is based upon the 0 to pi, that means cosine or sine, but the problem is not given that mention that Fourier cosine or sine. We need to identify logically that is the series is reduced in terminology that is sine, therefore we need to find the Fourier sine series. And sine series is nothing but, as we know that to find out the values are bn only, therefore the required series is f of x is equal to summation n is equal to that is 1 to infinity, that is bn into sine nx is the value. And where we need to find out the value of bn is nothing but 2 by pi integration of 0 to pi, that is f of x into that is a sine nx dx. And here also 2 by pi, we need to split the conditions 0 to pi, that is f of x sine nx, and again plus integration that is 0 to pi by 2, and again pi by 2 to that is a pi, that is f of x into sine nx into dx. And with the help of this one, we need to replace and again find the solution, we get the required solution, and after that we need to verify that that is a sine series only. And second one, if the series are limits are minus pi to pi, that minus pi to pi is nothing but we need to under the categories are we need to identify the series is either the even, odd, and also neither. The function is we are observing the problem is the function is clearly showing it is a neither function, because of it is not satisfied the even function, not satisfied the odd function. The function is satisfied the neither. That means we need to calculate what are the values are a naught and also a n bn. And based upon that, the required Fourier series is f of x is equal to, we need to find out f of a naught by 2 summation n is equal to 1 to infinity a n cos nx plus bn, sorry, nx plus bn sin nx, where the values are a naught is nothing but, as you know that the limits are minus pi to pi. Here the neither function means we should not change the daily limits, that is a minus pi to pi, that is f of x dx, and an is nothing but 1 by pi integration minus pi to pi f of x into that is a cos nx dx, and similarly bn is nothing but 1 by pi integration minus pi to pi f of x into sin nx dx. But in this problem, the functions are given like that, divided into like the two, split into the two functions. One is minus pi to 0 and again 0 to pi. That we need to find out according to 1 by 1 after replacement of the values. After getting that all the a naught, a n, b n values, you need to replace in the required series. And again after that verification, after that getting that, we need to verify this is the series. Whatever we are going to replace in the series, that is x is equal to, we get the solution. That is a deduce the condition is also given clearly. And next one, here also the problem is under the limits are minus pi to pi. Here the minus pi to pi is nothing but, again we need to identify the function is whether it is a even, odd, or it is a neither. Moreover, the given function is a particularly given what we are going to observing, the problem is based upon it is a even function. That is a, it is a not a odd function, not a like the neither function. The function is a even function. Because of the function is even function, it is satisfied f of minus x is equal to f of x is the condition. And based upon that, you need to calculate a naught comma a n only. And here the required series is that is a f of x is equal to, we need to find out a naught to play a naught by 2 plus summation n is equal to 1 to infinity a n cos nx, where the value of a naught is equal to even function. That means we need to replace 2 by pi integration of 0 to pi, that is f of x dx, and a n is a 2 by pi integration 0 to pi f of x into cos nx into dx. By using this is the formulas, we can replace that, and in between 0 to pi the function is applicable only this is the function, and again that is because of that 0 to pi is nothing but we need to consider that is 1 minus that is 2x by pi only, we need to assume that. And again here they are asking to find out only that actually that is a not a and b n only. We need to find out that bn is not required because of the function is a even function. Therefore, we need to find out a naught and also an. Actually, it is a required series is also not required to find the solutions. And find the Fourier series of the periodic function. It is defined in the interval and hence to the condition. And here also the limits are minus pi to pi. That function is a constant function as per according to the condition. The always the constant function is also even function. Therefore, here it is also it is a minus pi to pi, same as it is according to the above condition. First of all, we need to calculate only the a naught an, and again after finding that, we need to replace in the required series of f of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity a n into cos nx dx. And here a naught is the value of a naught is nothing but that is 2 by pi integration 0 to pi f of x dx, and a n is a 2 by pi integration 0 to pi f of x into cos nx dx. And with the help of these two formulas, we need to find the solutions, and again we get the solutions. And again after getting that, again we need to replace in the required series, we deduce the series also. Next one, determine the Fourier series, the representation of the half wave rectified signal. And this one, it is the limits are under that clearly, that is 0 to 2 pi. The limits are 0 to 2 pi. That means no doubt at all, we need to find out all the values are a naught, an and also bn. Therefore, the formula for it is f of x is equal to the required series is a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx is the value, where the value of a naught is nothing but 1 by pi integration 0 to 2 pi f of x dx, and again an is nothing but 1 by pi integration 0 to 2 pi f of x into cos nx dx. And similarly, the bn is also 1 by pi integration 0 to 2 pi, that is f of x into sin nx dx is the value. Based upon these are the three formulas, we need to find out that after getting that f naught, a naught, and bn, we need to replace in the required series. That is required, they are asking what they are asking, required the solutions. These are according to one by one, we need to find out while we recall the like according to the formulas. Yeah, here also the problem is period is 0 to 2 is given. That means period is 2, t is equal to 2. T is equal to 2 is nothing but it is a half range like periodic arbitrary periods only. And based upon this one, we need to find out that 0 to 2l, that is 0 to like 0 to 1, 1 to 2 periodic function period 2l only. That means 2. That means 0 to that is a 2l conditions. The 0 to 2l is nothing but as you know that according to find the values are a naught and an and also bn only. The formula as you know that is a f of x is equal to according to the formula a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by l plus bn, that is a sin n pi x by l is a formula, where a naught is nothing but it is a 1 by l into integration of 0 to 2l into f of x dl, and again an is nothing but 1 by l integration 0 to 2l f of x into cos n pi x by l into dx, and moreover the bn is also nothing but 1 by l integration of 0 to 2l f of x into sin n pi x by l into dx. Based upon this one, we need to find the solutions, we get the required solutions. Here actually it is they are asking to find out only the a naught, a and b n also, but this is also not required the Fourier series, not replacement in the series. And finally, it is a 0 to 2 pi, clearly given that under the limits are 0 to 2 pi. Here they are asking to find out only a naught and also bn. Not they are asking to find out that a n also, not required any asking like that any Fourier series. Only a naught and bn. That means required to find out that a naught is nothing but 1 by pi integration 0 to 2 pi f of x dx, and bn is nothing but here 1 by pi integration of 0 to 2 pi f of x into sine nx into dx. Based upon this one, you need to find out that a0 and bn only, and again we get the solutions. And here also it is clearly given same like that 0 to 2 pi, same according to the required series of this one. There is no changes of this one, but pi is nothing but it is given the only one conditions, that is pi is equal to L. Only that since replace that pi is equal, that is one is the conditions, and rest of the thing is same. We need to replace the conditions. And next one, find the Fourier series. They are asking to find the Fourier series. That is a minus pi to pi. The limits are minus pi to pi. That means we need to identify that is a even or odd and also neither functions. And here, moreover, the function is a not a even, not a odd. The function is a neither functions. Because of it is not really satisfied that my f of minus x is equal to, that is either the x or something, it is a minus f of x. Therefore, the function is a neither functions. And another neither functions you need to calculate, that is a required series is, that is f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an into cos nx plus bn into sin nx value, where the value of a0 is equal to, that means the value of a0 is as we know that the formula 1 by pi, there is no need to change the limits because of it is neither function. The limits are minus pi to pi, that is f of x dx. And again, an is the formula for 1 by pi integration minus pi to pi, that is f of x into cos nx dx. And again, finally, that is a bn is equal to 1 by pi integration minus pi to pi f of x into, that is sin nx into dx. And based upon that calculation of a0 and also an and also b0, we need to replace in the required series of f of x, we get the required solutions. Here they are not asking any, the deduce the conditions. And next one, find the Fourier series of periodic function. And here also the limits are minus pi comma pi. Here it is also, we need to check the function is even, odd, and neither. And moreover, the function is like not satisfied any even function, not odd function. Therefore, the function is a neither function. That means same as per according to the 10th problem, like 10th problem formula, we need to find the solutions. That we need to split in the two conditions, we get the solutions. Sorry, it is a not 9th one, it is a 9th problem. Same about the 9th problem, like the conditions, because of the function is a neither functions. Yeah. Next one, the limits are 0 to 2 pi. These are the like part A is completed, that is a critical thinking. Now it will be under the part B, that is the essay type questions. These are the 20 questions. While we are going to observe here, the function is find the Fourier series. The limits are under the 0 to 2 pi. The under the 0 to 2 pi is nothing but we need to calculate the values are a0 and also an and also bn. Therefore, the required Fourier series is nothing but f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity, and again an cos nx plus bn sin nx. And here also the values are, we need to find out the formula a0 is equal to 1 by pi, and there is no need to change something directly, it is a 0 to pi f of x dx. And n is nothing but 1 by pi integration 0 to pi f of x into cos nx dx. And bn is nothing but 1 by pi integration 0 to 2 pi f of x into sin nx into dx. And based upon these are the a0, an, bn values we need to find out. And again we need to replace in the by using these are the values, we need to replace in the required Fourier series. And after that they are asking to find out deduce the condition also. That means while we are going to replace something x equal 0 or pi something, that depend upon the equation getting, we get the solution. That we need to observation after calculation of a0, an, bn only. And here minus pi to pi, that minus pi to pi is nothing but we need to check the three conditions. The function is even, odd, the function is neither function. And moreover, the function is x cube is a odd function. That means it is not even, not odd, it is a odd functions. Odd function is nothing but you need to calculate bn. Therefore, the required Fourier series is f of x is equal to summation bn into sin nx is a value, and where n is equal to 1 to infinity. And again here the value of bn is nothing but, that is a odd function, is nothing but 2 by pi integration of 0 to pi f of x into sin nx into dx. Based upon this, by using this formula we can replace and again find the solutions. And again after that we need to replace in the required series, find the solutions. And next one, minus pi to pi. That minus pi to pi, same, the problem is above that, whether the function is a even, odd, and neither functions. Same like that, it is also not even not odd, we need to find out same as it is like above problem. That is like second problem, we need to calculate the solutions. Yeah, like that same condition only. And next one, 0 to 2 pi. That 0 to 2 pi is nothing but the limits are like, to find out a naught, an and bn. Therefore the required series f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. And here the problem is like that a naught is nothing but the where the values are 1 by pi integration of 0 to 2 pi f of x dx, and an is nothing but 1 by pi integration of 0 to 2 pi f of x into cos nx dx, and bn is nothing but 1 by pi integration of 0 to 2 pi f of x into sin nx dx. And next one, the 0 to pi. The 0 to pi is nothing but the problem is asking particularly it is a Fourier sine series. Fourier sine series is nothing but bn calculate. The value is f of x is equal to summation bn sin nx, where the value of bn is nothing but 2 by pi integration 0 to pi f of x into sin nx into dx. And similarly 0 to 2 pi also, like according to same like fifth problem, like fourth problem, we need to calculate. Based upon the fourth problem we need to calculate the solutions. And seventh one, the minus pi to pi, that is nothing but the function is a cos, it is a even, to find a naught and an, that is the required solutions. And again next one, minus pi to pi, that is minus pi to pi is nothing but the problem is based upon it is a neither function, means to find out a naught, an and bn, and with the help of the suitable formulas we can replace and find the solutions. And here also, that is minus pi to pi, the formula is neither function, to find out same here also a naught, an and bn, but additionally we need to find out that reduce the condition also we require to find out. And further it is also 0 to 2 pi, the limits here a naught, an, bn, and also deduce the problems, we need to calculate the solutions. Here the formula for a naught is a 1 by pi 0 to 2 pi f of x dx, and n is a 1 by pi integration 0 to 2 pi f of x into cos nx dx, and bn is a 1 by pi integration 0 to 2 pi f of x into sin nx dx. And here minus pi to pi, the problem is under the minus pi to pi, but the function is a neither, that means a naught, an, bn, and a naught is nothing but 1 by pi, under the limits are minus pi to pi, the neither function we should not change that any limits, that is a minus pi to pi, that f of x dx, and an 1 by pi minus pi to pi f of x into cos nx dx, and bn 1 by pi minus pi to pi f of x into sin nx dx. And next one is a 0 to pi. 0 to pi, the problem is given that sine series. Sine series is nothing but to find the value of bn only. Therefore, bn is nothing but that is a 2 by pi 0 to pi f of x into sin nx dx. The required series is f of x is equal to the summation of bn sin nx. And after finding the bn value, we need to replace in the required series, and again after that deduce the condition also they are asking. That means after getting that values we can get some idea. Based upon that we need to replace that either the x is equal to like the 0 or pi or something, whatever it may be, we get the solutions. It is also minus LDL. The function is neither to find a0, an and bn. And it is also the periodic function is 0 to 3. That means it is also clearly that is a 0 to L, because of they are not given that particularly half range or cosine or sine. It is given that periodic function is a to L. Then find the series of according to neither. Sir, not neither. You find out a0, an and bn. And after calculating L, here consider that 2L is nothing but 3, and again L is nothing but replace that 3 by 2 is the final solutions. And it is also 0 to L. Under the 0 to L, that means the function is arbitrary periods, and moreover we need to observe that the Fourier cosine series, that is a cosine series. Under the Fourier cosine series, we need to calculate only the values are a0 and an. That is based upon the formulas. And next one, the series is 0 to pi, but the problem is based upon the Fourier sine series. Series means that is a sine series means bn, you need to calculate, we get the solutions. And after finding that bn, again we need to replace in the f of x, we get the required series also. That minus pi to pi, it is clearly we need to observe the logical, it is minus pi to pi. The function is a even function, because of mod function is always it is reduced to even function. And if it is even function, we need to change that, find out only the values are a0, an. And again here that f of x is the required series is a0 by 2 plus summation, that is an into cos nx is the value. Provided a0 is nothing but 2 by pi integration 0 to pi f of x dx. And again here an is nothing but 2 by pi integration 0 to pi f of x into cos, that is a nx dx. And again after that getting that a0, an, bn values, we can replace in the required series, we obtain the proper solutions. And here it is a minus pi to pi. That means the function is a clearly neither function. And neither function is nothing but calculate a0, an and bn. And here the required series is f of x is equal to a0 by 2 plus summation an cos nx plus bn sin nx. This is the required series. And here a0 is nothing but that is formula 1 by pi integration minus pi to pi f of x dx. And again an is equal to 1 by pi minus pi to pi f of x into that is cos nx dx. And bn is a 1 by pi minus pi to pi f of x into sin nx into dx. And after getting all these values, we can replace in the required series, we get the required series of the functions. Last like that two conditions 0 to L, that is also considered that 0 to L, because of the function is not specifically mentioned any cosine series or sine series. That is a 0 to L. That is we need to find out a0, an and also bn, because of the function is a neither functions. We need to calculate. And here 2L is nothing but 5 means that is L is equal to, after that calculation finally we need to replace L is equal to 5 by 2. And it is 0 to pi. 0 to pi means the Fourier cosine series. The Fourier cosine series is nothing but to find out, that is a cosine series is nothing but to find out what is the value of a0 and an. That required formula we can replace and find the solutions, where a0 is nothing but 2 by pi integration 0 to pi f of x dx. And an is nothing but 2 by pi integration 0 to pi f of x into that is a cos nx into dx. And again these values we can replace in the required series, f of x is equal to a0 by 2 plus summation an into that is cos nx is the value. N is equal to 1 to infinity. These are the some standard type of the problems like essay type questions under the module 4. These are the 20 problems. The first 10 is a critical thinking. These are the 20 is essay type questions. And coming to finally that is a short type questions. And again these are the simple like that. Define a periodic function, that is a, and give the example like a periodic function means f of x plus t is equal to nothing but f of x for all values of that is a x only conditions. And again similarly, wherever the example is nothing but sine or cos, like that sine is nothing but 2 pi by n, like that formula, tan is nothing but pi by n is a value. State the even and odd functions. That even is nothing but, as we know that the function is f of minus x is equal to that is f of x, and odd is nothing but, as we know that f of minus x is equal to that is minus f of x is the conditions. These are the even and also odd functions. And find whether the following functions are even or odd functions. Here it is a plus 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 and again plus and again it is also plus, therefore it is a even function. And it is a minus to plus, it is a minus and again minus into, it is also minus minus of, it is a like odd functions. Like based upon the practice the problems, we get the some idea also where which one is a even function, which one is odd function, based upon the definition of the like definition of the even and odd function. Condition is f of minus x equal to f of x, and f of minus x equal to that is minus f of x is the conditions. And again here, primitive period of function, that is sine 3x and tan x is nothing but based upon the 2 pi by n, and also that is a pi by n. And according to in the beginning schedule given, that based upon that we need to find out. Because of for all values of sine cos like that, that is a 2 pi by n. And again the tan and the cot and again secant, the values are that is a pi by n is a value. And again here n is nothing but that is a 3, we can find the solutions. Next, explain the Fourier formula for the Euler formula for 0 to 2 pi is nothing but Euler formulas. That means a naught is nothing but 1 by like pi integration c2, that is alpha to alpha plus 2 pi into f of x dx. And again an is nothing but 1 by pi integration alpha to alpha plus 2 pi into f of x into cos, that is nx dx. And similarly bn is nothing but 1 by pi minus alpha to alpha plus 2 pi into f of x into sin nx dx. And next one, it is write the off range Fourier sine and cosine series of 0 to 1. 0 to 1 or something else, whatever it may be. It is for off range sine series. For sine series is nothing but the f of x is equal, that is a summation of that is n equal to 1 to infinity bn into sin n pi x by l into dx. And again the cosine series, we need to find out f of x is equal to, under the cosine series is a naught n beans, that is a naught by 2 plus summation n is equal to 1 to infinity n cos, that is a n pi x by l into dx. And again here you find out what is the bn value, what is the value, find the a naught and also an values. Next, write the examples of the periodic functions. The examples of the periodic function is nothing but same according to sin x, sin x, cos x, whatever it may be. Next, Dirichlet conditions. Explain the Dirichlet conditions and the existence of the functions, like means one, second one, third one, and also third one. It is a it is a bounded functions, and again it is a uniquely derivative exists. It is a finite number of like maxima and also minima conditions. These are the, and also the discontinuous functions at the point of that particular points. These are the Dirichlet conditions, already given one of the slides in the beginning sessions. These are the 4 conditions. And what are the conditions for the expansions of Fourier series in the, what are the conditions for expansions of function in Fourier series? Conditions is nothing but the functions or conditions are the like Dirichlet conditions, and again after that even function, and again odd function, and also based upon the neither functions. Based upon the given series, we need to find the solutions. Yeah. Next one, if f of x is an odd function in the interval minus L to L, then what is the value of a naught n value? And for example, minus L to L, the function is a odd function, only to find the values are bn only. That means since a naught comma n values are that is 0, we need to find out these are the values are not required, only find the value of bn, we need to find the value of bn only. And next one, here what is the value of b1? That is the condition. b1 is nothing but 1 by like L integration, that is 2 by L means that is 2 by L 0 to L, that is f of x, here that is a sin n pi x by L into dx. And since L is equal, that is a L only, because of here they are asking to find the solutions. This is the only they are asking to find out, that is a b1 value only. And again, what is a Fourier series sine? That is Fourier sine series is nothing but f of x is equal to, it is a sine series. That means summation of n is equal to 1 to infinity bn into sine nx dx, where the value of bn is nothing but 2 by pi integration 0 to pi f of x into sine nx into dx. Because of the limits are clearly mentioned, that is a 0 comma pi only, under that clearly Fourier sine series only. And again state Fourier series of a function in the interval 0 comma c to pi. That means the Fourier series under the Fourier series is nothing but the f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n into cos nx plus bn into sin nx into value. Where if it is required the interval in the 0 comma c provided c2, that is c plus 2 pi. If it is required the values are a naught is nothing but 1 by pi integration c2, that is a c2 c plus 2 pi f of x dx, and again a n is nothing but 1 by pi integration c to c plus 2 pi f of x into, that is a cos nx dx, and again bn is equal to 1 by pi integration c to c plus 2 pi f of x into sin nx into dx is the value. Next, similarly, define the Fourier series of a function in the interval is minus LDL. Fourier series, same like that, like as is according to f of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity, it is a n into cos nx. It is minus LDL is nothing but it is a n pi x by L plus bn into sin n pi x by L into is a value, where provided that a naught is nothing but f of x dl and n is equal to integration c minus LDL f of x into sin n pi x by L cos n pi x by L into dx, and bn is a 1 by L into, that is a minus, sorry, it minus LDL is nothing but 2 by L formula. A naught is nothing but 2 by L into integration 0 to L f of x dx, and bn is 2 by L into integration 0 to L f of x into cos n pi x by L into dx, and bn is the 2 by L into integration 0 to L f of x into sin n pi x by L into dx is the value. The next one, minus pi to pi. It is actually it is a minus pi to pi. The limits are, the function is a neither function. To find out a naught, a n and bn, but they are asking to find out a naught, that is the value is nothing but 1 by pi integration minus pi to pi f of x into dx is the value. We need to replace in the f of x into equal in the interval of minus pi to pi, that is x square minus x only. We need to find the solutions after replacement of that x square minus x. Explain the Fourier series for even function. That means, that is a function is even function means, as we know that the function is like f of minus x is equal, that is f of x. Here the depend upon the interval, that is a naught a n b l value only. We need to find the solutions. That is under the limits are particularly minus pi comma pi. Explain about the odd function. And odd function is nothing but the function is f of minus x is equal, that is a minus f of x. And again it is like examples are, it is required that examples x square x power 4 and again up to so on. And again the graphically it is like symmetrical about the like y axis, like other examples. And the odd function is nothing but to find the value of b, and the limits are minus pi comma pi. And again that odd function is nothing but x comma x cube comma up to so on. The graphically it is passing through the origin also. And 0 to pi, here 0 to pi, that is the limits are, they are asking to find out, that is a naught value only. That means 0 to pi is nothing but 1 by pi integration 0 to like the 2 by pi 1 f of x into dx. And we need to replace 0 to pi f of x, the function is given that x, we need to find the solutions. And minus pi to pi, that minus pi to pi is nothing but the function is like a naught value, that is a naught is nothing but that is 2 by pi integration 0 to pi, that is f of x into, that is dx is the value. Because of they are asking to find out only a naught only, we need to replace, and x is nothing but it is f of x is the cos x, and replace and integrating, find the solutions. Yeah. And finally it is minus pi to pi, the limits are, and again actually it is minus pi to pi, but the function is odd functions. That means only find the value of p n only. But the problem is given that a naught, therefore automatically the a naught value is 0 only. Because of the function is a minus pi to pi, the function is a even function only, we need to calculate a naught a n. But if it is a given function, it is here itself it is given the odd function, the value is a naught is n is 0. We find out only the bn value only. And these are the short type questions are also like these are the some problems. I hope everybody understood. And again, that Fourier series is very important, like interesting topics only that depend upon the totally to understanding the levels of the Dirichlet conditions and even function and odd function and neither functions. And moreover, the integrating by part, there is a Leibniz formula. While we recall all these formulas and again the basic formula, then only it is a survive. I think everybody understood. I hope it is good for us. And again, up to the previous lectures, we discussed like model 1, model 2, model 3, and this is the model 4 sessions. And in the further next session, we will go to discuss the module 5, that is a question bank, that is a multiple integrals. And again here, regarding this Fourier series, also in previous lectures we covered the limits are minus pi to pi, 0 to 2 pi, and again 0 to pi, and arbitrary periods. Individually, all the lectures we covered previously in lecturers. If you understand that here, easy to survive. Wish you all the best, and again good for. If any doubts are like further, if you are facing any doubts, please give the reply in the through link only. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.